Hi, my name is Kiran. I'm from section C level 5 and my student ID is 20251040, and we have three members in our group, myself Kiran, Smriti and Ranjana. Before running anything, I'm going to confirm that our Oracle login is completely empty. So no tables, no types, no object at all. So as you can see the query result, I'm gonna run all of the queries at a time. Um, So it begins with drop statement. To ensure the schema is clean, then create all our types, tables, sequence and the data and the corrected dependency order. As here we can also see there are all drop statement. The script start with drop statement for every object we create. Notice the order is important. Trigger and procedure are drop first, then tables in child to parent order, and finally the type. This ensure no foreign key dependency errors. The purge recycle bin at the end confirm everything is truly removed. Here we can see the purge recycle bin here. So we likewise we drop all the functions and all the object type as well in the above. Now let's move to the UDT object types. Our script create two user-defined types. The first is address type. This is an address object type that bundles street, city and postcode into a single reusable structure. Instead of three separate columns on a retreat table, we have one object column called location. The second is review object type. This object type represents a single guest review with a star rating, title and description. It is used as the element type inside our nested table collection. We also have two collection type. Facilities vary type is a vary with a maximum of 5 elements used to store on site facilities like a spa or gym for each retreat. Review table type is a nested table used to store multiple review object directly inside a program. Now I choose a vary for facilities because the number is small and bounded, and a nested table for a review because the number of review is unlimited. Likewise, we created 5 main tables plus an audit table. All primary key and foreign key are defined in separate alter statement. Following the module's good practice guideline, the retreat table used address type as an object column and the facilities vary type as a vary column. The program table include a nested table column called review table stored in a separate storage table called program review store. All our dummy data follow the good practice guideline. Every string values is stored in uppercase for consistent searching. Sequences generate all primary key automatically with different starting value per table. Here you can see the address type object column being queried using dot notation. Location.city and location.street, location.city.location.street, and this is how you access attribute of an object type column. The vary shows the facility list for each retreat. The final query use the table function to unnest the nest table inside programs. This is how oracles let you query collection data as if it were a regular table. That completes the schema setup, type, definitions, and data population. All 5 tables are created with correct constraint. Both collection type are populated with real data, and the object type columns are working as designed. I'll now hand over the rest of the topic to my friend Smriti. We will demonstrate about the procedure and functions.
Thank you, Kiran. My name is Smriti and my student ID is 20251106, and I'm responsible for the procedure and functions. I built 4 procedures and 4 functions. One is designed to perform a single well-defined business task. All use anchor type, declaration, parameters, and exception handling. Let me demonstrate each one. Uh, Procedure at program books a guest onto a retreat. Noticed I haven't passed a cost. The procedure calculates it automatically by fetching the accommodation price per night and multiplying by the number of night. It use anchor type parameters, so if the table structure is changes, the procedure adapt automatically. The upper functions ensure the name is stored consistently in uppercase. When I pass an end date before the start date, the procedure rise application error with a clear message, no row is inserted. This is our custom exception handling. Procedure cancel program updates a book status to cancel. The old status is checked first. If the book is already cancelled, a customer exception called EX already cancelled fires with a meaningful message. This prevents duplicate cancellations. Notice that audit trigger also fire automatically when we change the status. I will let Ranjana explain the rest of the code. Thank you. Before that, procedure add review to the relational review table. It validates that the star rating is between 1 and 5 using a custom exceptions, and also checks that the programs has been completed before allowing a review. Two separate custom exceptions handle these two different error scenario. Now this process use and accept split cursor declarations in the declare sections. The for loop iterates through every accommodations for the given retreat and update each price individually. You can see in the output that each accommodations is processed one by one with before and after price shown. Round is used to ensure price stay at 2 decimal places. Functions average rating returns the average star rating for the retreat. Unlike the procedure cursors, the functions use the full open fetch close cycles with the while or loop exiting while the cursors anchor not found attribute becomes true. When there are no review, it returns 0 instead of null. This is handled by the if check, not just NLV. Functions total revenue sums the total cost of the complete booking for a retreat, and VL ensures 0 is returned rather than null when no complete booking exists. Functions count programs except a second parameters for status filtering. The upper and trim built-in functions clean in the input before comparisons, and individual status raise application error. Functions get retreat summary use anchor row type to fetch the entire retreat row in one operations, then calls our other two functions internally. This demonstration functions reuse and interconnected design. The final query shows all three functions used directly inside a SQL select statement, something only functions can do, not procedure. This generates a live performance report across all retreat ordered by average rating. That's complete all 4 procedures and 4 functions. Each use anchor type, exception handling, and built-in functions throughout. I will now hand over to Ranjana, who will demonstrate the trigger, complex queries, and run the full test suite. Thank you.
Thank you, Smriti. My name is Ranjana Khatioda and my university ID is 20251070. And I am responsible for the triggers, queries, and testing. I built 3 triggers. Let me demonstrate each one. Trigger validate rating fires before insert or update on the review table. It uses a when clause. This is the conditional specification required for this document. The when clause evaluates the incoming star rating before the trigger body even executes. If the rating is outside 1 to 5, the when condition is true and raise application error fires. With the valid rating, the when condition is false and the trigger body is skipped entirely. An important syntax point: inside a when clause, we write new without a colon. Inside the trigger body, we write new with a colon. This is Oracle syntax and a common point. Trigger audit program fires after update of booking status on the program's table. Notice it only fires when the booking status column specifically is updated, not on any column change. The odd binned variable captures what the status was before the update, and new captures what it changed to. Syntax context automatically records the Oracle username who made the change. This creates a complete tamper-proof audit trail with no manual intervention required. Now, trigger update retreat status fire after insert on programs. When a new confirmed booking is added, the trigger calls Smithy's function count programs function to count confirmed bookings for the retreat. If the count reaches 5 or more, the retreat status is automatically updated to seasonal. This demonstrates a trigger calling a stored function showing the database object working together as a connected system. Now I will run a selection of our complex queries to demonstrate the range of SQL implemented. The inner join combines three tables, programs, retreats, and accommodations to produce a full booking report. To care formats the cost with a currency symbol. A left outer join ensures retreats with no reviews still appear in the results with a count of 0, and VL handles the null average for retreats with no reviews. Now, this query uses group by with having to filter retreats that have at least one reviews. Mean, max, count, and average are all demonstrated in one query. The minus set operator returns settings that have no retreat assigned. This is a relational algebra difference expressed in Oracle SQL. Finally, this query uses the table function to unset the nested table stored inside each program. Now, each review object becomes a query table row with its attributes accessible as regular columns. I will now run a section of test from our formal test plan to demonstrate the system behaves correctly under both valid and invalid conditions. All tests produce the expected result. Invalid inputs are handled gracefully with meaningful error message causes return 0 rather than null. The cursor based function returns exactly the same result as Oracle's native average aggregate function, confirming our manual implementation is correct. I am now running all the drop statement. The schema is now drop statement before submitting to the Twitter. Thank you for watching.